Hey, I'm Luke, and welcome to Conquering the JavaScript interview, where we do just what the title of the series implies. So, this one I think I'm marking as an intermediate because this is one that was very, what should I say? Like, very influential for me as a developer when I was first starting out years ago, right? This is one of the first ones that when I figured it out, I felt like a freaking genius, and it really felt like I had leveled up in my own coding experience when I understood this one, and I can explain it, especially when I started teaching and could very competently explain it to my students and also have them have their aha moments. And especially in a world where we stream lots of audio and video, it's good to know the basis of how that works when you see like your video or audio buffering. It's kind of using this process right here. It's not sending you the entire video on YouTube like this one all at once. It's actually sent it to you in small, well, chunks. And that's what we're looking at right here, like this fundamental concept of what we all get to enjoy in our modern life. So this particular function is called the array chunk, like I've been saying that word so far. The function will take two arguments, which will be an array of whatever elements. We're just going to do numbers to keep it simple for my visual output here in my terminal. And the second argument is a number that represents the size of the chunk. So basically, what this function needs to do is it takes that array, takes the chunk size, and it returns a new array that consists of subarrays of length n. And if there's any overflow, it just puts it into the next array. The important part is that it breaks apart into the appropriate chunks. So let's actually look at what that looks like here in these examples. So in this particular example right here, our original array is an array of 1, 2, 3, 4, and 5. Just five simple numbers. The argument for the chunk size is 2, and that should return the following array to us. JK, there we go. It needs to return an array that consists of subarrays of that chunk size of 2. So it'll create a chunk, and it'll put the numbers 1 and 2 into that small chunk, and that chunk is now at size length 2, which means it's time to go create a new chunk, take the next elements of 3 and 4, stick them inside of that chunk, say, oh, this is now length 2, so we're done here, create a new chunk, and we have an overflow of 5 that will just get slapped into its own chunk. But because there's no other elements left of the array, we are done, and that's what the return value should be with those as arguments. This one right here is going to have a slightly larger array as its input, going from 1 to 9, and it asks us to do an array chunk of 3. So the output should be 3 even chunks as subarrays of the array. So there's the new outer array, and each chunk, as we can see, 1, 2, 3, end, 4, 5, 6, end, 7, 8, 9, end. So that's going to be our 3 subarrays to solve this particular chunking algo. So like I said, this is a fun one, and I really felt like it leveled me up back in the day. So I'm going to mark this as an intermediate one, and it'll have some fun logic here. And there's actually 2 different ways to approach it, and I might break them into 2 different videos, depending on how long it takes me to explain the first one. I'll kind of wing it from my notes. Okay, so let's go ahead and get started on this one, and let's have some fun. So in our array chunk algorithm here, there's a couple of things we're going to need to know. We need to have our newly returned array, so we can call that like, const new array or something like that, or the chunk array. We'll call it the chunked array, for example. And that's going to be what this function will ultimately, as I tell you all in all these things, will return for testing purposes and stuff like that. Always remember to have that return keyword in there. Even though, again, it doesn't matter in this video's format because I just console log stuff for y'all. But in a real coding scenario, you'll always want to remember that return keyword. Okay, so clearly that's going to be the basis of this whole thing. We have to make a new array, fill it up with our chunks, and then return it on out of this function. That's the goal here, right? So we also know that we're going to be looping through the original input array right here. I like how I called the input argument R, and I actually wrote out array for the function name in that right there. We should be consistent and just call it R chunk and chunkdar. Just so I'm consistent with my own naming convention. There we go. I feel better about that now for some reason. But all right, so that's going to be the goal. And like I said, we need to be looping through each element of the array and determining whether it goes into a new chunk or starts or in the previous chunk, right? So if we're going to be looping through an array of elements, y'all know I'm a huge fan of the for of loop, so we can call this const element of R. This is going to be looping through each element of our input array, which whatever it happens to be. And now we have to have some kind of logic that tells us, hey, is this current chunk we're filling up hit the length of our input n? Like, has it hit our chunk length yet or not? Because if it hasn't, that means we put it in this current chunk and continue the process. If it has hit the length of the current chunk, we need to create a new chunk and then keep on going from there, right? So it sounds like we're going to have some kind of, well, conditional to determine whether we are in the previous chunk, or like if we're adding to the previous chunk or starting a new chunk, right? So first off, we have to actually get what the last chunk was in our array. So to do that, what we need to do is basically, we'll call it the previous chunk variable maybe. And what we're going to be doing is we're going to be looking in our current progress right here in the chunked array, right? In that chunked array, we need to, I just was looking at my notes to make sure I'm not messing something up. We are needing to look at the previous chunk if there is one, right? That's what this logic is going to allow us to do. We're looking in the current chunked array, and we're simply looking at its current length minus 1 for the element that we're working in. That's our previous chunk if there is one. If there isn't one, then we simply need to make a new one and add the element into it. If it exists, we then have to check its length, right? The previous chunk's length, to see if it's hit the n or not, the length that we were specifying for this particular function. And then from there, we simply, if it hasn't hit it, then we add it in there, and if it has, then we add it to a new one. And that's all it really boils down to. So this logic right here, it's kind of hard to wrap your mind around initially, but think of this logic as simply looking at as we're building this out, because at the very first iteration, there is nothing. So it should give us undefined, which means it should create a new chunk and add the number 1 in there as its logic. So let's go ahead and begin writing out the logic of our if-else statement, which will be the crux of this whole operation. There. So we have our if-else scaffolded, and like I said, all we have to do is say, if there is no previous chunk, or the previous chunk length has been hit, we need to make a new one. So we'll say new chunk with element, and this will be the logic for add to previous chunk. And by previous add to, I mean add element to previous chunk because its length hasn't been hit yet, or it doesn't exist, right? Or does exist, rather. So what we're going to have to do is going to say, if there is no previous chunk, that means we are starting out in an empty array, which means we have to add the chunk as another array with that element inside it. And again, we're presuming that this is going to be my initial call here with the element of the array of 1, 2, 3, 4, 5. So the first element will be a 1. So that logic is pretty straightforward. We're going to be using chunked r.push. Push is an array method, if you don't know, that adds an element to the end of an array. And what we're going to do is simply say add a new array with that element inside of it. So we've created the new chunk, we've put the element inside of there, and it should move on to the next iteration of our for loop, right? The previous chunk will say, oh, that is now this chunk right here, because the current array length is of 1 element of the chunked array. So if it's a length of 1 minus 1, that will generate an index position of 0 in the chunked array, which represents, surprise, this highlighted bit of code. This way, my camera's flipped. This previous array, I should probably flip it so the microphone doesn't look like it's coming out here. I set up a new canvas on my recording setup here in OBS, so I got my actual widescreen monitor since I have better equipment now, and I forgot to flip the camera, but oh well. So anyway, the 0th index position will be this array chunk, currently of length 1. So that's what we have to say. Do we need to make a new element, or is the previous chunk we're looking at have a length that is equal to our input value of n? This is the logic where we're going to say, is the chunk of its maximum length? Because if it is, then we have to make a new chunk, which, there you go. It'll go ahead and do that logic right there. If it's not of length n, which in this example is 2, then we have to take the element and add it to that chunk. Well, do we have that chunk's selected for us? We do. It's this variable called previous chunk. And we need to actually just push our current element into it because the chunk is not of the correct length. Okay, so that iteration of the number 2 in the loop we're going through here will add it to the previous chunk like so, and then it'll go on to the next element. The next element will be a 3, so here's what's going to happen. Chunked R will look at the current length of our chunked array right here, which is still a length of 1 because that's one element inside of it. So it's going to say 1 minus 1 to get the 0 index once again of the chunked array, which represents this small chunk right here in the blue the blue brackets. What it's going to do is it says, does it exist? It sure does. Or is the previous chunk, highlighted here, length equal to our input value? If our input value in this example is 2, this is indeed an array chunk of length 2. So what that means is that, that will then fire off the logic to say, create a new chunk and push it at the end of our chunked array with the current element. And then, as we can see from there, it'll do the following. Then it'll go to the next element, which will be the 4. And what it's going to do is say, look at our current chunked array length, which is an length of 2 minus 1 to get the first index position, which is that previous chunk. Does that previous chunk exist? It do. Does it have a length of 2? It does not. Therefore, simply push in the 4 into it. And now our loop will iterate to the element number of 5 in this original input right here to remind ourselves what I'm talking about. And it will say, hey, look up our previous chunk, which our current length is 2 minus 1 is the first index position. So previous chunk, the variable, now represents 3, 4 as a subarray. Is this chunk of length 2? It is, so it pushes a new array in with that element inside, and that's what our return value will end up looking like from this process. So it looks like logically we have figured out what this function needs to do, and now it's just a matter of console logging the chunked R and calling this function to see if we've solved it or not. Let's go ahead and take a look at calling our chunker. And I'm going to go copy my arguments from up here. Here we go. Boom. Shakalaka. So if we call this function, rchunker, with 1, 2, 3, 4, 5 as the input array with a chunk size of 2, save the file so it runs here in my terminal, and what do you know? We got our solution. We have an array with the subarrays of chunk size 2, 1, 2, comma, chunk, 3, 4, comma, chunk, and 5. If I change this to a 3, let's see what happens to see if it handles it correctly. It does. We have now 1, 2, 3 as a chunk, and then 4 and 5, and there's nothing left. Therefore, it's been successfully chunked. And let's go ahead and try it with this one right here, where we get an even 3 chunks. And boom. Yeah, let's go. We got it solved, boys and ladies, and everyone in between. We got it solved here. That's what I'm talking about. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like I said, this is a really cool and fun one that really made it felt like I leveled up back in the day when I figured it out. Hopefully y'all followed along and kind of saw the logic of how this ends up working out. And like I said at the beginning of the video, there's actually another way to solve this one using a while loop that's actually uses some pretty fun little logic to it. You know, I'll go ahead and include it here because why not? Take a snapshot, screenshot this, work your way through the logic. In future videos for intermediate video, like in advanced algos, I'll definitely like bust out draw.io or even MS Paint like XQC style, and then just make a diagram of how this works out. If y'all want that, get in the comments and let me know if you want some more visual aids to go along with some of these more advanced ones, especially when I start moving into like pyramids and steps and diamonds and whatnot, or calculating area. It can get kind of hard without having the visuals, but hopefully writing in like physical numbers to that chunked array as I talked through the logic helped. Now, like I said, there is an alternative here, right? So we're going to make a whole new function down here. I'll call it alt chunk. And personally, this logic makes the most sense for me. Loop through each element, look at the previous chunk if it's there. If it's not, add it with the element. If it's of the correct length, add a new one with that element inside of it. This is what my mind solved it the first way. But I had one of my developer buddies who I've been in my Dungeon Master in my D&D game I've been running for 3 years. Well, I play a fighter in that one, but still a D&D shirt. He came up with a different solution compared to this one. And I thought it was quite interesting that his mind worked a little bit differently because he was developing at a bank for quite some time. And I don't know if that will like really color like the way you approach certain problems, depending on what kind of programming you've been doing most of your life. But anyway, what we're going to do here in this particular function that's going to be different is we're going to be using a while loop, and we're going to do some fun array shenanigans with array methods. So what we have to remember is we still need to return a chunked array. Did I call it R chunked or chunked array? Chunked R. Chunked R. I'm trying to be consistent, right? All right, so that's our chunked array. Ultimately, we're going to have to be returning it no matter what. And we're going to console log it for visual purposes as we go here. I'm going to move this down a ways, and I'm going to call it alt chunk. So when it comes time to actually visualize it, we'll be ready to go. So what we're going to do here is we're going to need to have unlike for loops, which just iterate through an array and stop at the end of its length, while loops will continue until we provide a particular condition for it to stop. So I'm going to say let the index, my fingers are off home keys there. Let index start at 0 for our array. We're going to write our while loop scaffolding right here and say while our index is less than the input array length. As long as our index is less than that array's length, pretty much setting up the similar or same kind of for of loop up here. We have to provide our own condition for when the while loop needs to stop. Now, here's where it gets kind of fun. What we're going to do is we need to say into our chunked array, I need you to push a new array into it. But we're not going to actually make this new array by hand like this. We're going to be using a array method that happens to return an array to us. And if you know which one that already is, that is our slice, right? So an array slice will end up, of course, it's not going to show it is here because TypeScript, well, I'm not using TypeScript, so it can't assume that it knows what the array is. But if we look at array slice, what it does is it makes a copy of an array depending on our starting index position and our ending index position, and returns to us a new array with the copied elements inside of it. So that's going to be replacing the manually written square brackets that we had done for our logic up here to create the new chunk. This array slice returns a new array to us without modifying the original array of whatever we want to copy from the original array. So we're basically going to be saying, hey, starting at the index, which will be 0 initially, and going from the index plus the chunk length of n, make a copy of those values and then return a new array with them inside of that. So basically what that's going to be doing for our input of, say, this example right here of 1 through 9 with an array chunk of 3, it'll say, hey, starting at the original array now, index, which starting at 0, so that'll be the 1 right there, and ending at index plus n. So if an n is 3, 0 plus 3 will be 3, so end at 3. So 0, 1, 2, 3. And with array slice, this took me forever as a Nubian student to remember, it will end before the index that you want it to, right? Meaning if I say go to 3, it'll say 0, 1, 2, 3, and it will not copy the 4. It'll stop before that, to the left-hand side of where the stopping point needs to be. So what it's going to do is it's going to copy the elements of 1, 2, 3 and return them as a new array to this. So that way, that our slice logic returns that on the first iteration. That is our chunk right there, and it pushes that chunk into the chunked array like that. And that's what happens. Okay? Now, the next big thing about this particular solution is we have to increment the index not by 1 like we did in our for loop, our for of loop. We need to be incrementing it by however big our chunk size is to go to that next set of elements. So instead of saying index plus plus like you might have expected, we need to say index plus equals n. What this does is it says not go from 0 to 1, it says go from 0 to 3, 0, 1, 2, 3, because that's where the latest element is going to be that wasn't in the previous chunk already. So this is the big factor for this one and the way it works. So thinking out, again, talking out loud how this is going to go, we're going to be at index of 3, right? So it's going to say from the original array, slice from 3 to 3 plus 3, which will be 6. So it'll say, starting at 3, slice that in, right? 0, 1, 2, 3, yeah. 4, 5, 6, stop before that. So it's going to get 4, 5, and 6 now, sliced out and copied and added, pushed into the chunked array as those chunks. Then I'll increase that from 3 to 6, and the whole process starts over again, where it'll copy the rest of the array for us. And that should be it for the solution here. So let's go ahead and run this with alt chunk and see if she works. We got the same output, looking good in the neighborhood, if I do say so myself. Let's chunk this down to a 2 to see how it handles it, because we should have some overflow to see if it handles that properly as well. And it does. We have our 2 size chunks being outputted correctly with our overflow of 9 just chilling by itself, which is what I'm talking about, y'all. So that's 2 solutions to an intermediate and very fun algorithm that that is a surefire home run if you get asked this in an interview setting and can figure it out for your entry-level interviews. We've kind of branched out further than some of the previous algos that I've had in my playlist series here, and this is this is one of my favorite ones, and I was really looking forward to teaching it. If y'all want to see some more visuals involved with this, like I said, I can get into MS Paint or Draw.io and start actually helping out my more visual learners out there. But yeah, hope y'all like this. Like, comment, subscribe. As always, check the description below for getting involved in the Covalence community. And I'll see y'all in the next video. We'll tackle something else just as fun.